These are the 2.6 notes for PreCalc. Today we're going to talk about restrictions on the domain. So restrictions on the domain pretty much means what cannot happen in math problems. So there are two things that we cannot do in math. The first is you cannot square root negative numbers. Right? You can't take the square root of -4, not without getting imaginary numbers. And we are not going to deal with imaginary numbers quite yet. The other thing you can't do in math is divide by 0. If you did 8 divided by 0 in your calculator, you would get an error message. So what's happening here is we're thinking about if you were going to graph some of these things. Normally when we graph, we make a t-table and we just plug in random numbers. But if we ever have to plug in a square root of a negative or divide by 0, we actually can't do it. So that's kind of what we're determining here. What can't we do? So the first restriction is we can't divide by 0. We're going to talk about that one first. And when we're talking about dividing by 0 in a math problem, we don't use a division sign anymore. We use a fraction bar. So we have to make sure that in the level of math that we are working on, that our denominator is not equal to 0. Because if the denominator is 0, that means you are dividing by 0. So on example 1 and 2, we have a denominator, we have a fraction. So what we need to do is go through and make sure that our denominator is not 0. So when would we get a denominator that's 0? Well, if you look right here, most of you can probably recognize that if I plugged a -3 in for that x right there, I would get an answer of 0. Most of us can figure that out. If we were going to officially do that, we would take our denominator, say it's not allowed to be 0, so use the not equal to, pretty much the equal sign with a slash through it, and say it can't be equal to 0. And then you would just solve that very simple math problem. So subtract 3 from both sides. And obviously we get the -3 that we knew from the beginning. Now, this just means that you can't plug in a -3 and get an answer out of this. Otherwise, if I was making a t-chart, I would be able to plug in any other problem. I could plug in a 1, I could plug in a 7, I could plug in a -12, and I could plug those in for x and I can get an answer. But if I tried to plug in -3, it's not going to work. So what we do is we write the expression all real numbers. All real numbers can be written as an R with a double stick or even a super thick stick like that. So all real numbers. And if you don't feel like filling in that, you can just kind of write it like this, 2 sticks with an R through it. Okay. That means all real numbers. So our answer for this is all real numbers as long as x is not equal to -3, meaning anything works except for -3. All right, let's try the second one. So x minus 2. We just have to make sure that the denominator isn't 0. So you would do x minus 2 is not 0. You would add 2 to both sides. And you would say x can't be 2. It can be anything else, but it can't be 2. So in order to say it can be anything else, we're going to put the all real numbers sign in front. If you're feeling fancy, you can fill in that. If not, you could just leave it. So for this one, the domain is all real numbers as long as x is not equal to 2. Because if x equals 2, then we have a problem. You get an error message in your calculator. The restriction number 2 is going to be our square rooting of the negatives. So you can't square root negatives. So what that means is what's underneath the square root can't be negative. In math, we're not going to say can't be negative. We're going to have to say 0 and higher. So underneath the square root has to be greater than or equal to 0. You can take the square root of 0. That's fine. All right, so under here, we have to make sure that x plus 2 is 0 or higher. In other words, x plus 2 is greater than or equal to 0. And you subtract 2 from both sides. And that's it. And you would put your all real number sign in front. Meaning if I was going to ask you to create a t-table out of this, you can use numbers as long as they are from -2 and up. So -2, -1, 0, 1, 2, 3, 4. All those numbers would work. Anything smaller, though, than -2, you wouldn't be able to do. It would give you an error message on your calculator. So that's all we're trying to determine. We're not trying to graph these, but if you were trying to graph these, that kind of helps you decide what your table looks like. Problem number 4, the 3x minus 12, I have to make sure that that is greater than or equal to 0. So you're always using that same symbol for these. If you see the square roots, you're going to be using greater than or equal to 0. The rule doesn't change. Add 12 to both sides and divide by 3. So if I was going to make a t-chart and start graphing these, I would want to use numbers from 3 up. All right, so the last part is a restriction 1 and 2 happening together. So notice it's a square root in the denominator. Square root in denominator. So it's 2 things happening at the same time, the 2 rules happening at the same time. So in order to do that, we have to combine these 2 rules. It has to be greater than or equal to 0, and it has to be, and it has to be not equal to 0. So when we take the greater than or equal to 0 and add it with the not equal to 0, this greater than or equal to sign, this or equal to sign can actually cancel out with a not equal to. Those disappear. So together, those make just greater than. So if you see something in the denominator, square root in the denominator, you have to say it's greater than 0. All right, so 5 and 6 are examples of a square root in the denominator. So I take what's in the square root, and instead of using the greater than or equal to, instead of using the not equal to, I'm just going to use the greater than. Add 1 to both sides. All real numbers as long as x is bigger than 1. For that one, it means I actually could not use 1 because 1 is not greater than 1. So I'd have to use numbers bigger. So I'd probably start with a 2, then work myself up to a 3, a 4, a 5, etc. All right, example number 6. So I'm going to take what's inside, and since it's a square root and a denominator, I'm going to use this symbol. And for this one, be careful, I'm actually going to need to subtract 2 from both sides. And I want to get rid of that negative in front of the x, so I'm going to divide by -1. Since I'm dividing by a negative, I am going to need to flip my inequality from a greater than to a less than sign. And -2 divided by -1 is 2. So now I have all real numbers as long as x is smaller than 2. So if I was going to make a t-table out of that, I would start with my next smaller number, whole number. I would use 1, then 0, then -1, etc. Now we only have 2 restrictions in math, which means a lot of problems that we do have no restrictions at all. So if you don't see a square root and you don't see a denominator, that means there are no restrictions and your answer is all real numbers. And remember, your symbol for that is the R with a double stick, or if you prefer, the R with the filled in, almost like a bold R like that. But on example 7 and 8, I don't see any square roots and I don't see any denominators. So that means I can plug in any number I want and there are no restrictions on my domain. All right, if you have any questions, please let me know.